Well, let's see. First off, just to put the right spin on it, right, we're here to not talk about a scrub. In fact, we're still going to launch on Friday, so that's good. So I'll take back all those bad things you guys say about me and schedule, because I get to do two in a day. And we actually had another record. We had the shortest MMT ever today. So, but basically, just to kind of lay down what we talked about is the teams have been working really hard over the last several days. We did some test data last night that came in fairly late in the afternoon, evening time frame. The teams went off and talked about what that data meant. We talked about some possible forward plans. They got back together this morning, and it became pretty apparent pretty quick that we had really good rationale. We had a really good story, but the teams that needed to polish it, do the double checks, make sure that everybody could see it, bless it, and do it, were the same teams that within another hour had to go on console and do the tanking. And then I needed them to be on console for launch and to stay sharp. And then you also got to factor in if we did have a weather scrub, they'd have to come right back tomorrow and do it again. And when we looked at that and we started to judge our readiness, we basically said, you know what, the better part of valor here is to take a day, let us go polish that off, really make sure we understand what's going on. And so that's why the MMT part of the meeting was very short. We basically made the management decision that while we were probably getting very close technically and we could probably keep going, it just wasn't the right thing to do from a pressure standpoint, and so we gave the team a day to go keep working on it. We then kind of ended that MMT with a plan to set up for tomorrow, gave some actions to Pete and his team, which he'll talk to you about, to make sure that we could protect the rest of the launch opportunities in the window for us. And then we let the technical team get to the meat of the discussion about talking about the failure they had, the troubleshooting we did, and what the forward plan would be. And really, just to kind of back up, we're talking about the valve we're talking about is a valve we call PV12. It's a LH2 liquid hydrogen inboard fill and drain valve, a big 8-inch butterfly type valve that sits one of two in series that we use to fill and drain the liquid hydrogen from the external tank. When we tanked the last time, that valve, we told it to close and it didn't show us closed, and so we had to drain to go check and do some testing. That testing happened last night. We did 5 cycles at ambient pressure, and ambient I mean no cryo in the system, no liquid hydrogen in the system, and all 5 times that valve did exactly what it should. The traces looked perfect, and the closed indication came on and said that the valve was closed. We then did a decay check where we basically put some pressure on the upstream side of that valve and just let it sit for an hour and watch for that pressure to decay to prove that physically the valve truly also was closed. This position indicator is actually on the gear mechanism that turns the valve. It's not on the valve itself. So the closed indication tells you that the gear drove as far as it should to put the valve in a closed position, but it doesn't actually tell you the valve itself is closed. So the decay check was our real proof positive to say that, yep, that valve indeed was fully closed. Now that gave some of the team some pause, and this will sound funny, but because the test passed and performed perfectly, folks were worried now that that meant we should be no-go. Because if you get back into cryogenic conditions and the indicator does not come back, how do you verify that the test at ambient temperatures and pressures can be correlated to a test at cryogenic temperatures and pressures? We thought we had a decent story there, but that's what kind of led us to say we need a little bit more time to truly understand it. If we would have tried today, our posture basically would have probably been something along the lines of go tank and see what happens, and if the close indication shows up and works, great, go launch, and if it doesn't, scrub and try again. And that's just not great. I mean, that's not really a scientific way of going about doing our business. So we wanted to say, if we're going to go through the process of tanking up the vehicle, putting that cryocycle on the external tank, having everybody ready to go, the dangerous conditions we have out at the pad to do that, we need to have a plan in place already that if that close indication doesn't come up, what can we do to convince ourselves that on launch day we have data, secondary data, that we can look at to be highly confident that it is indeed closed. Really, and that's why I said the team was 80-90% of the way there already today. That data would be basically some of the secondary indications. Obviously, the closed indicator is one of those indications. Another one would be the cycle times that it takes for the valve to go from the open state to the closed state, or the closed to the open, based on the actuator command, power commands. That timing is a very fixed, repetitive timing, both at ambient and at cryo cycle. So we can go back and see how this valve performed over every other time it was in cryo conditions and cycled. And as long as the timing worked just right and looked exactly the same, then that would give us good confidence that the motor drove long enough to put the valve where it was supposed to go. The way this thing works is actually kind of interesting. It's actuated by pneumatics, which means that we use helium to push a piston around. And rather than just put 750 psi helium shoving into a piston and slamming it down to the end of its travel, we actually charge the other side of that with the helium, And so we kind of fill the downstream side, we fill the upstream side, so the pressures are equal, and then we slowly bleed off the downstream side, so the valve very slowly goes open or slowly goes closed. That bleed off dumps that helium into the aft compartment, and we have hazardous gas leak detectors right nearby that can pick up on that. So another good indication is the amount of helium that gets dumped into the aft compartment can be measured, is also very repetitive and very accurate, and that tells you had full range of motion. If you had less than full range of motion, you wouldn't ever get to the end of that piston travel, and the circuit would not complete itself to, say, shut off the helium that's being used to pressurize this upstream side, and we'd continue to put helium into the system, continue to bleed it overboard in the aft compartment. So in addition to the hazardous gas detectors in the aft compartment, we could look at the reg pressures feeding that system in the main propulsion system and see that they still had demand on them to tell us that the valve didn't quite get to where it wanted to go. So all those secondary cues are in front of us. We had them available to us on console on launch day, the first day, and Pete very, I think, prudently recommended from the team, rather than trying to real-time create this as we go, we ought to scrub and go get into a safe config and talk about it. That's what we did. We got ourselves safed and talked about it and realized that, you know what, we want to make sure we're ready if we're wrong. We want to make sure we really do understand that there's not some other mechanism that we're not quite smart enough to think of yet that wouldn't be affecting us, that might fake us out on some of these other signatures. So what the teams are going to do is look at all this data that is very repetitive and very gives us very high confidence the valve went where it was supposed to go. How accurately can we truly measure that the valve didn't just go 95% of the way shut? And when I say shut, I need to make sure I remind you guys, we talked about this is a very strange valve. There's basically a blade that rotates in and blocks the flow, and then it lifts up to a seal and presses against that seal. So as this gear actuator drives, it spins 270 degrees. The first 180 degrees of that lowers that blade down or raises that blade up, and then the last 90 turns it out of the way. So to close this valve, it's out of the way. We rotate 90 degrees, and then we spend 180 degrees of drive shoving this thing up against its seal. That limit indicator comes on at the very last couple of % of drive. And so you really would have a closed system. You might not have complete compression of that blade against its sealing surface. So you might have a little area where you could burp past that valve. That's really what we're talking about. We're not talking about a valve that's partially open. We're really talking about a very small leak path past there. And again, one of the reasons we stopped is it's a good example of how we do our job. The teams went off and looked at what we can do to be able to fly, and then they stopped and said, okay, and if we're wrong, what's the consequence? And one of the consequences here is that if that valve doesn't get sealed up after liftoff, or right at startup, I should say, when we close the outboard fill and drain valve and start draining that system, if there's leakage, liquid hydrogen will bleed back through into this little cavity, which will then turn into a gas and bleed itself back into the main engines. And ingesting gas into that main engine helium manifold is probably, or hydrogen manifold, is probably not a good thing. There's a little bit of it that we can tolerate. And so really what the team's going to do overnight too is just double check all that math to see that we really do have some confidence that even if we do have a tiny little bit of leakage past this valve, it would be what we consider spec leakage for this valve, and that we'd be okay and confident. So to make sure we had a true bulletproof story and we really knew what the teams on console would execute when we see or don't see this closed indicator either there or not there, we decided to give them one more day. And a lot of that factor really played into the fact that it was the same set of teams that was going to do tanking as had to develop this rationale, and we wanted them to make sure they were fresh and ready to go. So that was the logic behind the reason to give them one more day. Everything still points that it is a valve position indicator. We didn't see anything in any of the testing or any of the analysis that makes us think that this truly is some other phenomenon. We reviewed all the testing we have of how these valves in the past have galled, which is the metal binding in this camshaft. The LCC that tells us not to cycle that valve was really built to protect for that hazard. We've then, since that time, developed screening techniques that we put in place every single flow where we, rather than putting 750 psi of helium and moving this valve, we go in with 20 psi of helium and move it extremely slowly and look exactly at how much resistance is in that valve. And you can see that increase as time goes on and the dry lube wears out. That then gives you a condition which could lead to galling. We replace those valves before we get there. But the point being, we have very good screening criteria to show that we should be nowhere near galling condition in this valve. We should be nowhere near metal binding and worried about a condition where it seizes up and is unable to move. So that gives us good confidence that on launch day, if the valve doesn't show us what it should, we can cycle it a few times to go get repetitive timing data to say, hey, we're going to cycle it 2 or 3 or 5 times. That data is repetitive to itself, and by the way, compares very good with how this valve has always performed in the past. That would be our flight rationale to say we're good to launch that day. So that's what we're going to do. We're going to let the teams build that. Tomorrow at noon, we're going to come back with an MMT, look at that plan, make sure we get it blessed. We're going to talk about the risks because we are not going to be able to prove the valve is truly closed. We're going to have extremely high confidence that it is closed, and so we want to talk about the unknowns there and the risk there of being wrong. After that MMT, we'll roll into a tanking weather briefing. We'll talk about the weather, make sure we truly look good. We'll talk to Pete and his team to make sure the vehicle's been in good shape, and at which point I suspect we'll be perfectly ready to give a go for tanking and a launch attempt tomorrow. I think it's a 23:54 window open tomorrow night, Friday night, so just barely Friday. So that's our plan and our go-ahead plan, and I can let Pete talk to you about all the rest of the stuff that goes along with that decision.